This video is for Unit 1.2 Energy Pyramid Model. So you should be following along with the Unit 1.2 guided notes as well. In this vodcast, I'm going to talk about how the energy pyramid model actually describes the amount of energy passed through a food web at each level. In the previous video, I showed how the energy pyramid model is kind of like a food chain in showing which organisms eat what other organisms, but it takes that a step further to show energy amounts as well. So that's what we'll go over in this video. So here's your typical energy pyramid. And in this energy pyramid, we're going to do 4 levels, because remember, oftentimes an energy pyramid doesn't have more than 4 levels, and we'll talk more about why that might be in a minute. Recall that down here in the bottom level, we've got our producers. So we're going to write a P for producers. In the second level, we have the primary consumers. Third level is the secondary consumers. And the top level is those tertiary consumers. So I'm going to label each of those for you. Examples of things that we can find in each level. This should be really easy for you by now. We can find plants. Oh, I better spell that right. So again, plants. You can find mosses, algae, trees, ferns. Remember, these producers are anything that goes through photosynthesis, so they can take the sun's energy and use it directly for energy for their food. That's why they're called producers. Next level up, our primary consumers are those things that eat producers directly. So anything that eats plants, mosses, algae, trees, ferns. This could be a variety of things. This could be a mouse. This could be a grasshopper. This could be a rabbit. This could be a raccoon. The next level up, the secondary consumers. These are anything that is going to eat the primary consumers. So anything that eats a mouse, let's see, what might eat a mouse? A snake. What might eat a grasshopper? A bird, like a robin perhaps. What might eat a rabbit? Fox. And what might eat a raccoon? Maybe a coyote. Okay, and then our last level up, those tertiary consumers, anything that eats a primary consumer. There aren't as many of these, remember. They're a little bit harder to come by, but what might eat a snake or a bird or a fox or a coyote? We're going to go with our old standby, the hawk. Okay, so this is kind of a review of what you know about energy pyramids already. Now let's add in some new information. The first thing I want to talk about is that energy transfer. So when a mouse eats a plant of some sort, it's getting energy from the plant. And that energy that it's getting from the plant, we can draw with an arrow. So the plants move their energy to that second level, those primary consumers, the mice. And when the mouse gets eaten by the snake, it also moves its energy to the snake. When the snake gets eaten by the hawk, it moves its energy to the hawk. So this kind of mimics a food chain here, because food chains show with arrows the direction the energy is moving. But the other thing I want to point out to you is that in each of these levels of the energy pyramid, we're actually looking at different sizes of these levels. And with those different sizes of levels, for example, this bottom level is a lot bigger compared to the top level. What that is actually indicating is the energy. So each level on an energy pyramid, its size equals the energy. So in other words, our producers down here have the most energy available to them because they can get energy directly from the sun. And when they get eaten by the primary consumers, their energy level is already depleted because those plants have used that energy for growing, for photosynthesis, for reproduction, all of those things. So what we need to understand then is that not all of the energy moves from the plant to the mouse. In actuality, it's only about 10 of the energy that moves from the plant to the mouse. And when that mouse gets eaten by the snake, it's already used some of that plant's energy as well. So of that 10% that the mouse got, it moved around and used some energy, it reproduced and used some energy, it grew and used some energy. So only 10% of its energy, on average, is transferred to the snake that ate it. And then the same with the hawk. The hawk only gets 10% of the snake's energy once it eats that snake. So each level of the energy pyramid is only passing on 10% to the next level. And this means that our energy level gets smaller with each step up. And that again is indicated by the size of those different steps. So we're going to add in a couple new vocab words to this as well, now that we've talked about energy and the passage of energy. This bottom level that I outlined already in yellow has a special name when it comes to energy, and that name is autotroph. Auto meaning self, troph meaning feeding. So the plants can feed themselves with the sun's energy, so they are autotrophs. All of the rest of the consumers in levels 2, 3, and 4 need to feed themselves by eating something else. So they are called heterotrophs. Hetero meaning other, and troph meaning eater. So they have to eat something else in order to get their energy. So they are called heterotrophs. So all the consumers, primary, secondary, tertiary, they are all heterotrophs. The autotrophs are the producers. All right, one more set of vocab words we can add to this, and that is one hopefully that you're familiar with: carnivores, herbivores, and omnivores. So anything that eats an autotroph, or a plant, is considered a herbivore. So all of these primary consumers could also be called herbivores. And I'm sure you've heard this word before, so this shouldn't be too new. Now, anything that eats only plants is an herbivore. Anything that eats only animals is a carnivore. So for example, a fox, a coyote, a bird, a snake, some of them might actually eat plants as well. A hawk, for example, however, only eats other animals. So that hawk is our carnivore. Okay? So what do we call these animals, for example, these in the middle here, that eat both animals and plants? They have a special name as well. They are called the omnivores. So you can see within one energy pyramid, some organisms have many different names. We're going to look at that next. So let's take a sunflower. Think about what are all the names we could apply to a sunflower. So pause the slide for a minute and see if you can think of all the different vocab words we could apply to a sunflower. All right, a sunflower could be a producer, and it could also be considered an autotroph. Next, I want you to think about a honeybee. What are all the things it could be considered? Again, pause the slide, think about it, and then come back. A honeybee eats nectar from various plants. So it is a consumer, and it's a primary consumer because it eats plants. This also means, because it's a primary consumer, we can also call it an herbivore. And then finally, because it can't make its own food but has to eat something else, we call it a heterotroph. All right, raccoon is the last one. Again, pause the slide. See if you can come up with all the names for a raccoon. Okay, a raccoon eats both plants and animals. So it could be a primary consumer if we're talking about it eating plants. It could be a secondary consumer if we're talking about it eating animals. It could be an omnivore because it's eating both plants and animals. And we can also call it a heterotroph because it cannot make its own food. It has to eat other organisms in order to get energy. So there you can see a little bit better the complexities of all these vocab words and where they overlap. All right, next we're going to do some sample problems with this idea that 10% of the energy is passed on. So I'll read through the first one with you. This is also on your guided notes, so you'll want to show your work in solving this as I go through this as well. Question 1 says, if 1,000 calories of energy are available to our dandelion. So here's our dandelion, and it has 1,000 calories of energy. How much energy is transferred to our cow that ate it? Here's my really bad drawing of a cow. We want to know how much energy did that cow get. We also want to know how much energy is transferred to the person who ate the hamburger, which was obviously made from the cow. So that is our second unknown. All right, remember that only 10% of the energy gets passed on at each level. So let's take it step by step. If we want to find out, starting with 1,000 calories, how much is passed on to the cow, then we need to know what is 10% of 1,000. So a way to write that is what is, or what equals, 10% of 1,000. Is always an equal sign, of is always a multiplication. So we're solving for this unknown by taking 10%, which remember we can write as a decimal, times 1,000. So there's our equation. When you put that into your calculator, you get 100 calories. You can also figure that out without a calculator by simply moving the decimal point one spot. The decimal point's here, moving it one place because it's 0.10, so there's only 1 0. You only move the decimal point one spot. That gives you your actual number, 100 calories. So our cow has 100 calories. That takes place at the first question. Now we need to look at, of that 100 calories from the cow, how much did that person who ate the hamburger get for energy? So again, if we're starting at 100 calories, same method as before, here's our 100 cow calories. We need to know what is 10% of 100. And again, solve that by 0.10 times 100. You can put it in your calculator or just move the 0 one place, and we get 10 calories. So our person, by eating the hamburger, got 10 calories from that original 1,000 that the plant provided to the cow. This does not mean that the hamburger had 10 calories in it. It just means that if we track that original 1,000 calories from the plant, only 100 are in the cow and only 10 get to the human. So again, we're seeing the decrease as we go up. Remember our energy pyramid. As you go up the energy pyramid, the energy level decreases. Let's do one more problem. This one says there are 175 calories in an apple. Here's my apple. 175 calories. How much energy is already used by the time you eat it? Now this is different because this isn't asking how much energy you get from eating the apple. This is how much energy did the apple use before you got your energy from the apple. But in order to solve that, we still have to figure out 10% like we did in the last problem. So we want to know what is 10%. I'm just going to start writing this as a decimal. of 175, because that's what our apple has. And that's going to move the decimal point one spot. That equals 17.5. So of those 175 calories, you got 17.5. Okay, when you ate it. And that's because the apple used some of those calories. How do we find out how many calories the apple used? Well, we take what the apple started with, we subtract the calories you got, and that equals the number of calories the apple actually used. Now, how do we figure that out? On the calculator, 175 minus 17.5 equals 157.5 calories. So that was what the apple used up for growth, for reproduction, for photosynthesis, before you even got to eat it. All right, that is the end of the problems. Again, make sure that you filled out all of your guided notes for this section, and then also there is a feedback form that you need to finish to prove that you've actually watched this video and done a little work to go along with it.